For homework 6, you will need to implement a programming assignment to do with Bayesian networks. This is the Bayesian network that we will be evaluating. This is a simple diagnostic network where the variables are characteristics about the patient, such as whether they smoke or not, whether they have visited Asia or not, some symptoms such as whether or not they have dyspnea or whether or not they have tested positive for an X-ray which shows some occlusion in the lung area. And there are 3 possible conditions that they may have, which is tuberculosis, lung cancer, or bronchitis. And our goal will be to write a program that will evaluate the a posteriori probability of each of the 3 possible diseases given some combination of evidence. For example, you may be given that the patient has visited Asia and has a positive X-ray, and then you need to figure out which disease is most likely. The probabilities associated with this network are given as follows. They are also available in this paper where this example was originally published. Let me explain what these things mean. Alpha is the variable about Asia, which has a probability that somebody has actually visited Asia is 0.01. As a consequence, the probability of not visiting Asia, that is the probability of not A, is 0.99. So those probabilities are implied in this description. So this is not all the possible values that you will need to encode. Please note that. Similarly, the probability of tuberculosis, given that somebody has visited Asia, is 5%, whereas in general, if they have not visited Asia, it's 1%. As a consequence of this, the probability that somebody does not have tuberculosis if they have visited Asia is 95%, and the probability that they do not have tuberculosis if they have not visited Asia is 99%. So the converse probabilities need to be inferred for each possible case in this description. Don't forget that in your encoding. Once you've encoded this, you will be given evidence and asked questions about the a posteriori probabilities, or rather the most likely explanation, that is the best diagnosis given the evidence. For example, given no evidence whatsoever, what is the chance that you have tuberculosis? Well, the answer is just over 1% if you believe this belief network. Your program can encode these probabilities in tables and use SQL the way we have described in class to evaluate the required a posteriori probabilities for each condition. Using SQL makes it easier, and this network is certainly not too big for any SQL engine to handle. SQLite 3 in Python, which is built in, is a good thing to use, or you can use any SQL engine, or you can encode the network directly using any algorithm that you may wish to read up, but the one that we've covered in class is SQL. So this is the assignment. Please implement your program, try it out for different possible conditions, and then open homework 6 to try and answer it. It will be a timed homework as before, so that I am sure you're actually using your program. But there will be enough time to run your program, type in the conditions that are given, and get the answer and answer the homework. Good luck.